Hi, PLMS. Sorry about the delay here. We are going to be working with finding out if a function is linear or nonlinear today. I can determine whether a function is linear or nonlinear given a sequence, graph, verbal description, or table is our I can statement for today. Our first display is going to be a table. In order to figure out if a set of data is linear or nonlinear given a table, we have to find the change in the x's and the change in the y's and determine if it's the same value. So you can see here that on the x's we have it increases by 2 each time, where on the y, look, it's increasing by 18, then 34, then 50. So that would say that it is not a constant change, therefore this function is nonlinear. If I were going to do this, I would write m is equal to the change in my y's over the change in my x's. So I would have 18 over 2, which breaks down to 9. I would have 34 over 2, which breaks down to 17. And then, of course, 50 over 2, which breaks down to 25. So you can see that that is not a constant rate of change. Again, I emphasize it's a change in the x, or the change in the y's over the change in the x's. So now it's your turn. Determine whether the table represents a linear or nonlinear function. Explain. Find the change in your x's, find the change in your y's, and then you can determine which of these answers is correct. The answer is B, linear. The rate of change is constant. So the rate of change for my x's here would be 2. This is a plus 2. It's a plus 2. It's a plus 2. Down here we had a plus 4, a plus 4, a plus 4. So the change in the y over the change in the x's is a constant rate because it's a 2 each time. Determine whether the table represents a linear or nonlinear function. Explain. So once again, we're going to find the change in the x's. Find the change in the y's. And we can agree that that is linear because the ratio 9 over 3 breaks down to 3 each time. Determine whether the table represents a linear or nonlinear function and explain. So go ahead and do this example, and when you're ready, start the video again. This one says nonlinear. Nonlinear rate of change is not constant. So let's see our rate of change. We have a positive 2, a positive 2, a positive 2. That looks constant to me. But on the bottom, we have a positive 5, a positive 6, and a positive 8. So when I break that down, 5 over 2 is definitely not equal to 6 over 2, which is not equal to 8 over 2. Therefore, it is nonlinear. Determine whether the graph represents a linear or nonlinear function. So here, when we talk about linear, we know the root word of line. Does this look like a line is the question. And I think that you can say that, no, that doesn't really look like a line. It looks more like a curve. The graph is a curve, not a straight line, so it represents a nonlinear function. What about this one? Is it a line? If it's a line, it's linear. If it isn't a line, then it's nonlinear. What do you think? The answer is B, nonlinear graph is a curve, just like our previous example. Determine whether the graph represents a linear or a nonlinear function. Explain. Does this look like a line? I think it does. The graph is a straight line, so the rate of change is constant. The graph represents a linear function. You may have guessed that. So what about this one? Determine whether the table represents a linear or a nonlinear function. If it's a line, then it's linear. If it's not a line, then it's nonlinear. C, linear, the graph is a straight line. Determine whether y is equal to 5x squared plus 3 represents a linear or nonlinear function. Explain. What we're going to do here is concentrate on the exponent. I see 5x squared. Since the power of x is greater than 1, the function is nonlinear. Answer, nonlinear. Since x is raised to the second power, the equation cannot be written in form y is equal to mx plus b. Whenever you have a variable and it's raised to the second power, we actually call that a quadratic, and we will get to that later on this year. Determine whether y is equal to x squared minus 1 represents a linear or nonlinear function. So what I want you to do on this problem is pay attention to if there is an exponent greater than 1. If there's an exponent greater than 1, then the function is nonlinear. So go ahead and make your guess. Nonlinear, power of x is greater than 1. So D is the correct answer. Determine whether y minus 4 is equal to 5x represents a linear or nonlinear function, and then explain. Well, in this format, it's difficult to see. We know that, or maybe you don't know that, I'm just going to tell you that an equation is in linear form when it's y is equal to mx plus b, and it's not quite there yet. So we need to move the negative 4 to the other side, which would make it a positive 4. So in order to do that, this negative 4 then, it doesn't want me to write, is going to come over here, and that's going to become a positive 4. So now, is this in the format y is equal to mx plus b? Then it is linear. So you might have to do a little changing. So first of all, we notice that the exponent of x is 1. We know that if it's greater than 1, then that is not going to be linear. But now we see it in the format y is equal to mx plus b. Determine whether negative 3x equals y plus 6 represents a linear or nonlinear function. The first thing you're going to want to do is put it in the format y is equal to mx plus b. Then you can make your decision. The answer is B. Yes, it is linear. It can be written in the form y is equal to negative 3x minus 6. So once you move over your negative 6, because it's a positive 6 on the right, but when you move it over to the left, it's going to become negative. So that's going to be y is equal to negative 3x minus 6, and that is a linear function. We'll talk more about it later, but that's because negative 3 is your slope, and negative 6 would be your y-intercept, or the place the graph crosses the y-axis. Here is a real-world example. Use the table below to determine whether or not the number of revolutions per hour that the second hand on a clock makes is a linear function of the number of hours that passes. So we want to find the change in our y's and find the change in our x's and figure out if that is, in fact, a common ratio. They're showing it a little differently. I would just do the change here. It tells you what the change is each time. So that's going to be positive 60, positive 60, positive 60. See where this is going, positive 60. And then over here, we're just changing by 1 each time. So as you can see, the ratio is 60 each time. Now it's your turn. Use the table below to determine whether or not the sum of the measures of the angles in a polygon is a linear function of the number of sides. Figure out your change in your y's over your change in your x's, and then make your decision. The answer, yes, it is linear. We have a change of what, 180 each time here. Every time it's going to be positive 180. And over on the x's, then it's just a change of 1 each time. So our ratio is 180 over 1. I'm trying to erase that, not scribble it out. You get the point. I hope you enjoyed your lesson over linear versus nonlinear today.